Hey, how you doing? Today's question will sort of build on yesterday's question about ionization energy. Why does sodium have a larger ionization energy than rubidium? Okay, so compared to a lot of elements, neither sodium or rubidium have what you would consider a huge ionization energy. And the reason is that they both only have one valence electron. And since they have only one valence electron, in order to get a complete valence shell, they would either have to add 7, yeah, I got it right, that's 7, or they would just have to lose the one that they have and then go backwards. So you could either take 7 steps forward or 1 step back. And so that goes along with what we already know about metals, in that metals, when they form ions, never gain electrons, they always lose electrons, okay? So the fact that sodium and rubidium both have sort of lower ionization energies is almost beside the point, though, when you consider why does it take more energy to remove an electron from sodium than it does rubidium. And with a lot of things, it comes down to the electron configuration. So the electron configuration for sodium, do it with me here, 1s2, 2s2, 2p6, 3s1. Whereas rubidium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1. And so if I was going to mark the valence shell here on sodium, it would be 3s1, and on rubidium it is 5s1. So if I set up Coulomb's law, F equals K Q1 Q2 over R squared, you'll notice that rubidium will have a lot more protons than sodium, so that can't be the answer, because rubidium actually pulls with more protons than sodium does. But two things here come into effect is that the radius has to be much, much bigger. And so if you consider like the 1 shell is really close to the nucleus, and then the 2 shell exists outside of that, and then the 3, and then the 4, and then we're all the way out into the 5 here. And so this is going to be much bigger. The R number is going to be much bigger for rubidium than it is for sodium, because this electron here is going to be much farther away from the nucleus. The other thing is that sodium this electron is shielded by a grand total of 10 electrons. And then this shielding is 10, 20, 30, 36 electrons. So that's not something that's really easily quantified in this equation, but since we're good chemists, we do know that shielding is a thing that would lower the overall energy needed, just because whatever's pulling from the nucleus of rubidium is blocked by all these 36 electrons, and whatever's pulling from sodium is only blocked by 10 electrons. So if you were to ask, why does sodium have a higher ionization energy than rubidium, you would answer that the radius of rubidium is much larger, and there's more of an effect of shielding. I'm going to say that one more time. The radius of rubidium is much larger, and there's a bigger effect of shielding.